All right. So next week, vast majority. Lecture's going to start at 7:35 and we're going to have a review. If you voted that you didn't want to come to a review, you can come in at 9. That is when the exam will start. The exam will start at 9 and you have until 10:30 to finish it. Okay. So from 7:30 until 9, we're going to do a review before the exam. It's going to be a little cram session with Dr. C. That's how that'll work out. Okay. All right. So that's what the decision of by far. Okay. What else? Folks, next week is week 12. Why does that scare me? It should scare you. If you are in that non-passing grade right now, week 12 is the last day to drop the class with a W. You stay beyond the class, you're going to get a letter grade, whichever you earn at the end of the class. Heads up. If we need to talk about that, I need to get an email from you before next week. Not last minute. Okay. It's flying. Okay. It's going to be week 12. We come back week 13. Week 14, 15. Week 15 is Thanksgiving week. Week 16, we come back and we have our finals. I'm letting you know, I'm a little stressed out. Your stress is causing me stress. My stress is causing you stress. It's just a vicious cycle, but we'll get through it. All right. You guys know what you need to do to get through it. We're going to focus on the lymphatic system and the respiratory system today. So that means on our next lecture exam, it's going to cover the blood, the heart, blood vessel, lymphatic, respiratory, 5 chapters from the next lecture exam. All right. The lymphatic system. We're not going to give it a lot of love. We're going to do a quick review over it. Not a lot of people give this. Some people don't even talk about this system in anatomy courses. You will hear very little bit about it in physio. And it's an important system. Why is it an important system? What is it responsible for? What is the lymphatic system responsible for? Your what response? Your immune responses. So you're going to have your lymphatic vessels, your lymph vessels, those shown in green. You have the little bulges. Those are your lymph nodes. Those are important. Your tonsils are part of your lymphatic system. Your thymus gland is part of the lymphatic system. The red bone marrow, the spleen, and one of my favorites, it's abbreviated the MALT, the MALT system. These are some of the major structures, organs of the lymphatic system. We're going to break it down, talk about how the lymphatic system does its thing, what it does, and a little bit, just a review of what each of these parts do. As the blood moves through the arterioles, the blood is eventually going to make its way into the capillaries. So this network is the capillary network. This is important. The capillaries that are part of the lymphatic system They are fenestrated. Who remembers what that means? They have big holes or small holes? They have small pores. They are leaky. So what's gonna leak out of those pores? No, it's pores. The pores are too small for cells to leave the blood. The pores are, so what leaves the blood at the fenestrated capillaries? Something that's a part of the blood is going to leave. The plasma is the leaky part. That is important. The fluid inside of the blood is the plasma. And get this, the minute it leaves, it's no longer called plasma. So the minute it steps out the door into the interstitial space, it is no longer called plasma. What is that fluid called? Interstitial fluid. The minute the plasma leaves the blood out of the fenestrated capillaries, it becomes interstitial fluids. This is the fluids that's going to surround and soak the interstitial cells, the connective tissue. So in the capillaries, it's plasma. The minute it leaves, it is now interstitial fluid. We have to remember what's inside plasma, what's inside interstitial fluid. The nutrients, gases, ions, minerals, everything that the blood carries is dissolved in the plasma. So as the interstitial fluid moves, oops, I drew it the wrong way. As the interstitial fluid moves out of the blood vessels, it's just going to kind of soak all of those cells, do exchange nutrients, exchange waste products, exchange everything with the cells. Plasma leaves the blood vessel. It becomes interstitial fluid. Then here's where the lymphatic system comes into play. The lymphatic system is going to bring that interstitial fluid inside of it. That interstitial fluid moves into the lymphatic capillary. That is a lymphatic capillary. It's going to drain the interstitial fluid. It's going to move the interstitial fluids into its vessels. Here it is, moving in, moving in. The minute it's inside here, it is no longer called interstitial fluid. What are the fluids inside the lymphatic vessels called? Does anybody know? It is simply called lymph. Lymph is the fluid that is inside the lymphatic vessels, the lymphatic capillaries. There's a lot of exchange happening here. A lot of students are just going to tell me the lymphatic vessels filter the blood. That's a zero. How does it do it? The plasma leaves. The interstitial fluid moves into the lymph. The lymph fluid now gets filtered. It's going to get into this, and the lymph is going to flow into a lymphatic vessel. The lymphatic system, its job is to clean and detoxify the lymph. So it's cleaning the body fluids, folks. Lymphatic capillaries are always going to be next to blood capillaries. So the blood capillaries are shown there in blue and red. And the lymphatic capillaries is the network that's shown in green. So those capillaries in green are the lymphatic capillaries. It makes sense. They need to be next to the capillary so that they can draw in those interstitial fluids. So when the interstitial fluids enter the capillaries, that is now lymph. And look, the lymph is going to flow up these lymphatic vessels. It's going to make its way through these little ones, these tiny, tiny bulges. Those are valves. We're going to talk about what the valves are for. And then it's going to make its way into this structure that I'm going to outline in black. This is one lymph node. That lymph fluid is going to flow through it, and then it's going to flow into the next lymph node, the next lymph node, the next lymph node. They're going to go through a bunch of lymph nodes. As they make their way through the lymph nodes, one of the things that's going to happen to that lymph fluid is it's going to be cleaned. You have to understand how it's going to be cleaned. We're going to talk about that here in a bit. But then that lymph is going to return to the blood. It's going to return to the brachiocephalic veins. Once it returns to the brachiocephalic veins, it becomes plasma again. So yes, as it makes its way through this, it does get filtered, but you have to tell me, how is it getting filtered? It has to make its way, and by it, I mean the plasma has to leave the blood, becomes interstitial fluid. The interstitial fluid enters the lymphatic capillaries. The lymph fluid moves through the lymph nodes, and it'll eventually make its way back into the bloodstream to do it all over again. But the idea is, once it's here, it is now clean lymph, clean fluid. It will become clean plasma. And tell me for A, where are the lymphatic capillaries going to be located? Next to the blood capillaries. Look, here are the blood capillaries. And the lymphatic capillaries are going to be located right next to them. What happens at the lymphatic capillaries, folks? What are you going to tell me? Interstitial fluid enters the lymphatic vessels. Interstitial fluid enters the lymphatic vessels and becomes what? And becomes lymph. That's how I want you to answer that.
Where does the filtering happen?
We'll get there. We'll get there. So the interstitial fluid enters the lymphatic vessels and becomes lymph. That is what is happening at the capillaries, folks. Okay. The lymphatic vessels move the lymph to the lymph nodes. The lymph will continue to move through the lymphatic vessels. The downside with the lymph is the lymph doesn't have a pump like the heart. The only thing the lymph has are these unidirectional valves. These valves that are located right, let me try a better color. They're located right here, are unidirectional valves. That means they allow the fluid, the lymph fluid, to only move in one direction. So as you walk, which we should be walking a lot, your muscles are going to squeeze those lymph vessels and force the lymph to go in the direction that it wants it to go in. Here, this is the histology of a lymph vessel, the dark part. And if you look very carefully, you're going to be able to see a unidirectional valve here. That means the lymph is designed to flow in that direction and only in that direction. So it can make its way back eventually to the brachial cephalic vein. So that's where the lymph is going to move through, but there is no pump. So one downside to this is these are very prone to infections, and in some parts of the world, parasites. And what they'll do is they will block that lymph flow. And as a result, people will get edemias, a buildup of lymph fluid in their extremities. That's just the lymph fluid building up in their tissues. It can be painful. Some people don't feel a thing. It's just heavy. Okay? Because there is no pump to force this through other than your muscles. So if something blocks it, in some countries, there are mosquitoes mosquitoes transmit parasites, and those worms will live in there, and they just block the whole thing. And those people are left to suffer with these swelling of the appendages. Be genetic too. So the lymph vessels move the lymph through to the next area. Okay. So now listen to this question, because this is getting at the same thing I asked you earlier, just asked in a very different way. Which fluid enters the lymphatic capillaries, folks? Interstitial fluid. Where is it coming from? Where is it coming from? Why am I struggling with this word? Let's try one more time. Interstitial fluids. It is coming from the cells that are surrounding the blood vessel. It is coming from the interstitial space. The connective tissues that surround the blood vessels, all connective tissues. So, if there are any bacteria, fungus, virus, worms, guess what? They're going to make their way into the lymphatic capillaries, and they're going to move through with the lymph. That's the point. Move those parts, those elements into the lymph fluids so we can process them. What ensures that the lymph flows in one direction? What do you call those? And unidirectional means moving in one direction. And there are valves located in the lymph. That's the only thing that's keeping it flowing in addition to your muscles. No heart that helps move those through. I've never understood this, but you're going to see this when you guys go work in your doctor's offices. Okay, as a heads up, each one of these bulges, you're going to see that there's a bunch of them here. Each one of those is a lymph node. Each one of those. And I've never really understood it, but I guess it makes sense. You're going to be in a doctor's office and they're going to call this part your axial. Your axillary, your axillary nodes, just a patch. It's a group of them. So sometimes they'll just call that group the axillary node. And it's a ton of them. What do you think they call the ones over here? The ones your doctors check when they're checking your neck. Your cervical node. Axillary, cervical, and the last one that gets checked most often, inguinal. Those nodes, you can see there's a huge collection of them. Your doctors will check for them. Because what happens if they're swollen? If they're swollen, what does that tell your body? What does that mean? Sorry, what is that indicating that's happening to your body? You're fighting an infection. If they're swollen for 3 months, what type of infection do you think you're fighting then? Cancer. Nodes help fight infections. That's their job. If you have cancer in the head, you're going to have very swollen cervical nodes. If you have cancer in your arm, you're going to have very swollen axillary nodes. If you have cancer in the lower legs, you're going to have swollen inguinal nodes. They're indicative to those areas. Okay. So they'll just call it a patch of nodes, so like a cervical patch or just the cervical node. Let's talk about what is happening when the lymph gets to the nodes. The lymph nodes themselves, so here we have a lymph node. Here's one of them. As the lymph moves into them, there are multiple points of entry. The entry is the afferent vessels. Remember, that means the fluids arriving to the lymph nodes. What do you think the one that is leaving the lymph node is called? This is efferent vessel. There's only one efferent vessel per lymph node. There are multiple afferent vessels. So here's what happens. The lymph node, look, there's a valve, so it only moves in, won't move back out. Will travel in these pink, light pink areas. Those are called sinuses. And they'll just move through the sinuses until they get to the center, and then eventually they'll make their way out. That is one pathway that it can possibly take. But this area in pink, that area that I'm kind of highlighting in black here, that is called a sinus, a lymphatic sinus. So the fluids will move through those pathways and they'll coil through the lymphatic node. There are two general regions of the lymphatic node. The very center of it, you can kind of see this dashed line. I'm going to outline it. the very center, that is called the medulla of the lymph node. So all of this in green, where the blood vessels are, there's sinuses, and there are other structures in there. We'll talk about that here in a bit. But that area in green is called the medulla. Medulla means central. This other word, the outer area, we've seen this word also. It means outer. That is the cortex of the lymph node. So the lymph node, as it moves through, it's going to go in the cortex, into the medulla, out the cortex, into the medulla, and eventually make its way out. So it's just going to coil in there. And it can be random how it moves through these lymph nodes. Okay. So as the lymph makes its way through the sinuses, it's going to take this windy path. And it's unclear how it's going to get through, but eventually it can do this, can get in the center, it can go back through again, but eventually it will make its way out. But here's what's happening. Here's what's crucial. As it moves through this area, as it moves through the sinus, here's what's happening to the lymph. As the lymph moves through this, it is being exposed to a bunch of cells. And I need you to know what these cells do. We've already talked about these. What do monocytes mature to become? At that point, they are macrophages. Look at that. What are the macrophages going to do? Any bacteria, any fungus that's in the lymph is going to get exposed to macrophages. There's a ton of them there. There's going to be in other groups of cells. What do lymphocytes become? They become T cells. What else? B cells, and those are all going to be abundantly present there. So any bacteria in the lymph is going to have to survive that gauntlet. It's going to have to get through a bunch of macrophages, a bunch of T cells, B cells, and NK cells. The macrophages want to eat them. The NK cells want to eat them. The B cells and T cells want to recognize them so they can make antibodies against them. So as the lymph moves through each lymph node, your body is going to effectively fight off any pathogens that have moved into the lymph fluid using primarily monocytes and lymphocytes in that area. This is how it is filtered. You need to know which cells and how they are responsible for filtering. Don't just say filter. Explain to me that they physically are going to be the cells. The macrophages and NK cells are the ones that are going to consume and digest any pathogens that are in there. And the B cells and the T cells are going to work on developing antibodies against additional pathogens. Which one of these is pointing to an afferent vessel? A and B. There are multiple afferent vessels on a lymph node. You can even see the arrows there. Do you see that the fluid is moving in? When the fluid moves in, where does that fluid end up? The lymph fluid. The sinus, in which layer? Which region? In the sinus of the cortex. That is the answer to this. Sinus of cortex. Which one of those arrows would you say is pointing to the cortex? D. What is E pointing to? The medulla. And C? The efferent vessel. As the lymph moves through, as the lymph fluid moves through the lymph node, what happens to the lymph? What are you going to tell me? It's exposed to the gauntlet. What are macrophages going to do to the bacteria in the lymph? They're going to destroy it. They're going to engulf it and digest it. NK cells are going to do the same thing. They're going to engulf any bacteria, fungi moving through the lymph and digest them. What about the B cells and T cells? What are they going to help generate? They're going to create the antibodies, because guess what? You cannot phagocytosize viruses. The only way your body can neutralize viruses is with antibodies. Okay, that's a lie. But that is the easiest way your body can neutralize viruses. So the lymph is going to be exposed to mainly those 4 cells. And they're going to remove any foreign objects. They're going to develop an immunity to viruses moving through the lymph. Lymphocytes. What do they become? Lymphocytes that are exposed to the hormones in the red bone marrow. Red bone marrow. Remember, the red bone marrow is where your cells are made. All of your white blood cells, all of the leukocytes are made in the red bone marrow. One of the things that this does is it releases hormones to the lymphocytes, and that's going to tell the lymphocytes which cell to become. If a lymphocyte receives the hormones from the red bone marrow, they can become 2 of the cell types. Remember, bone marrow, B cell, bone marrow. Or it can become the NK cell. Lymphocytes will only mature to become B cells and NK cells if exposed to the hormones produced by the red bone marrow. Where do T cells come into play? The lymphocyte has to move into your thymus gland. Your thymus gland, one of its main jobs when you have an infection is to release thymic hormone. So the thymic hormone, is going to tell the lymphocytes to become T cells. Look at that. T for thymus, B for bone marrow. T cells and B cells are going to work together to produce the antibodies. So these 2 organs are crucial for making the mature lymphocytes that are going to be crucial for your immune responses as the lymph moves through your lymph nodes.
Are T cells and B cells? Are T cells just in the lymph nodes? Or
No, They can be in other tissues as well. They're going to be in high abundance in the thymus and the brain fart, the lymph nodes and the spleen,
And the B cells can be
anywhere. The mucosa associated lymphatic tissue, MALT. This is the malt. Remember, the malt is part of your GI tract. So here is a section of the small intestines. Pay attention to this. The malt is kind of a modified lymph node. So in the walls of your intestine, so when we look at the histology, this region right here is the malt. This region right here is the malt. They are essentially modified lymph nodes. So they're going to hold a lot of macrophages, NK cells, B cells, T cells. They're going to hold a lot of those materials. Because when you eat your food and it moves through the lumen of your gut, all of those nutrients are eventually going to be absorbed and make their way into the blood. Well, your lymph nodes is your first line of not your lymph nodes, your malt is the first line of defense against any bacteria, any viruses, any fungi, worms that come in through your food. No matter how well you prepare your food, it will always have some bacteria in it. And you need your malt to help regulate it. So the malt is essentially a lymph node that is specifically designed to help you process the nutrients you bring in. So you don't end up with a nasty case of the shits. That's literally what it's there for. It's all over the small intestines. All over. The other structure that acts like a lymph node are your tonsils. You have 1, 2, 3 sets of tonsils. Your tonsils, shown here, are also a modified lymph node. So when you breathe in the air, guess what? There's going to be airborne pathogens. Those pathogens are going to make their way to the tonsils. And the idea here is if the pathogens make their way to your B cells and your T cells, they can start learning how to make antibodies early on. Because the timing of making antibodies, the sooner you can recognize the pathogen and make antibodies, the better. So as you breathe in these airborne pathogens, they're going to help make antibodies as part of your immune response. Okay. So your tonsils are part of your lymphatic system. Many people always ask me, what if I get my tonsils removed? Well, you just have one less shield. You have 2 more. Right? Normally when people get their tonsils removed, they get their sublingual tonsils removed because they become infected, they become swollen, and they need to come out. So the malt and the tonsils are modified lymph nodes to help you fight off infections in fluids other than lymph. These are not processing lymph. That's one thing I failed to mention. These are processing things that are coming in, the liquid in the air, the liquids in your foods, the liquids that are part of your drinks. Those are the ones that they're processing. Question A should really ask, where do most lymphocytes, like 99% of them, mature into B cells? What are you going to tell me? In the red bone marrow. What structure in the pharynx serves as a modified, specialized lymph node? The tonsils, okay? Those process the air, the water, and the drink because it has to go through the pharynx when you breathe, eat, or drink. The last organ that we're going to briefly cover of the lymphatic system is the spleen. Okay, the spleen, I need you to be familiar with. I need you to be familiar with its major functions. Okay. One of them, your erythrocytes. This is where your erythrocytes, this is where they are recycled. Your erythrocytes only live 90 to 100 days max, depending on which pathway they take. And after that, because they don't have a nucleus, don't forget, they don't have a nucleus, they can't repair themselves. So they need to be broken down and recycled. This is where you will recycle the hemoglobin, so you don't lose that iron. Okay. When you break down cells, think about it. Your system is constantly breaking down cells. Sometimes your own cells break down. When you break down a bacteria, those parts are just going to be floating through your bloodstream. Well, your spleen removes all of the debris that builds up, all of the waste products from broken down cells. What does that? In your spleen, you have a ton of macrophages, monocytes that help just phagocytize, break everything down, digest it inside of them. There are a ton of them. And I always find this interesting. One of the things that it does is it stores blood platelets and a bunch of monocytes stored. So when your body thinks it has an infection, it'll send them to swollen, possibly infected areas. So it'll keep them stored in the spleen, and when your body sends a signal, we've been bit by a mosquito, we're going to swell up that area. Your body's going to send a ton of platelets, a ton of monocytes to that area if it needs to fight off an infection. So it stores them in the spleen before it sends them off. These two regions in black occur in this area of the spleen. That area of the spleen is called the white pulp. It is white because that is where there's a lot of leukocytes, a lot of platelets being stored. A lot of monocytes, macrophages there. Lots and lots of them there. The red pulp All the area in red is where your erythrocytes are recycled. So when you cut open a spleen, you're going to see areas that are like a light gray and areas that are like almost a black. The white pulp and the red pulp. Okay. So I need you to know what is happening in the red pulp versus what is happening in the white pulp. Which of those parts happen in which of those regions? These are the three major functions that I'm going to hold you accountable for the spleen. So when the blood gets through there, blood is typically going to go through the white pulp first. Then it will continue its track and make its way into the red pulp. And eventually it will be reabsorbed or drains out the splenic. It's called the splenic vein. Okay. So it moves in, travels through the white pulp, typically first, then the red pulp, before it is drained out the splenic vein. It enters from the splenic artery, which is this one. So this is all processing blood, directly processing blood. Some people can survive without the spleen. Not a good thing to have. Don't just go chopping off your spleen. But people can survive without it. They will have issues with iron regulation. They will also have issues. They'll just be more susceptible to getting sick because their bodies don't send platelets and monocytes to infected areas. They'll be missing those two major parts. Like I said, we don't give the lymphatic system a lot of love. One thing I failed to mention, I hate doing this, but I'm going to have to do this. I had to go backwards because I was supposed to mention it here or, oh my goodness, or here. When the lymph moves through the lymphatic vessels, it's usually going through many lymph nodes, not just one. This one's showing two lymph nodes. In this image down here, let's say you go, the lymph is collected here. It's going to go through 1, 2, 3, 4, 5, 6, 7, 8. It's going to go through a ton of lymph nodes before it finally gets back into the brachiocephalic vein. And it takes its sweet time getting there. It's not rapid like the blood. It's a much slower flow. Exposed to many, many lymph nodes on its way back. Respiration. Here we go. Respiration. What is the function of respiration? What is going on there? Okay, gas exchange, breathing. Are they all the same thing? No, not really. I need you to know what respiration is, which organs are responsible for it. And it does get quite confusing. Okay. When you breathe out, what is breathing out called? Expiration. What about when you breathe in? Inspiration. We're going to stick to those physiological terms. Don't tell me inhalation. Don't tell me breathing out. Exhalation. Inspiration. Expiration. Breathing in, breathing out. When you breathe out, why is there a bunch of cloud stuff on a cold day? What's all that? What's going on there? What about water? You have to understand what's happening with water during respiration. Do we say exhaling? Okay, good, good. You expire, just like milk. The respiratory tract. If you're breathing appropriately, you should be breathing from your nose. What is that hole called? Nostril or nares? When air goes in, it goes into which cavity? Which cavity is this one? Your nasal cavity. A lot happens at the nasal cavity. Who can tell me at least 3 things that are happening there? What does that mean?
If it's dry outside, it adds moisture to the air.
So you maintain water in the air. That's important. So you need to temperature control your air. What's the last thing that happens there? Traps bacteria. Traps infections. That's what all your boogers are for. All those hairs. They're designed to trap stuff from going, not just bacteria, dust, right? Dander. It's designed to trap it all. One of the main reasons you should be breathing through your nose. What is this region in the back? The pharynx. That is your pharynx. Then you have your voice box. What is the name of the voice box? You will not call it a voice box. Your larynx. Right there. Everything above this is your upper respiratory tract. So when they say you have an upper respiratory tract infection, you have a sore throat. You have an infection in your larynx, your pharynx, your nasal cavity. That's your upper respiratory tract. Everything below it is your lower respiratory tract. Where does it start? This part. What is this part called? The trachea. That is the first major windpipe. It'll branch off and become 2. Those are your bronchi. Bronchi. Eventually, those will branch off. Those will branch off. Those are all bronchi. Bronchi. At the very end of the bronchi, these are softer. These are smaller. These are your, oh, I forgot the N on bronchi. Sorry. These are bronchi. These are bronchioles. Small bronchi. And at the very end, you have millions and millions of air sacs. What are your air sacs called? Alveoli. What is the objective of your respiratory tract? No, not diffusion of gases. What's happening in all of this whole tract? But what's the major goal? We're not there yet. We're not at the diffusion yet. Inspiration, expiration. Moving air in, moving air out. We're not at diffusion yet. The whole respiratory tract is designed to move the air in, move the air out. Yes, the air gets, you meet the appropriate, what is it? Water vapor. You meet the appropriate temperature. Yes, you filter the air. But the main objective is to move air in and out of this tract. What is the major driving muscle? The diaphragm. The diaphragm is right below the lungs there. When I say respiration, and this is going to be important in physio, respiration is the gas exchange. Ventilation is what? What is ventilation? There's 2 steps to ventilation. What are the 2 steps of ventilation? We just said them. Inspiration and expiration. So what is ventilation? It's as simple as air in, air out. That is ventilation. You will say inspiration, expiration. Those are the words you will use. So what is respiration? Gas exchange. So I'm going to ask you, what is external respiration? And many of you who are not listening right now are going to tell me that's moving air in and out, and that is absolutely wrong. Because what is respiration? Exchange of gases. Where do we exchange gas? External respiration. Right here. So between your pulmonary capillaries, the capillaries in your lungs, and the air in the alveoli, look at that. You're doing gas exchange between the blood and the air. That is where external respiration is happening, between the alveoli and the pulmonary capillary. What's happening here? Look at CO2. CO2 is being secreted. What does that mean? What does it mean for something to be secreted? What is it doing at the lungs, folks? It's moving out of the blood into the air. It is leaving the blood. That is what it means to be secreted. What happens to oxygen? At the lungs, folks, at the alveoli. What's happening there? It gets moved into the blood. You will say O2 is absorbed. Those are the words you will use. Secreted, absorbed. That's what's happening during external respiration. It's relative to the blood. CO2 is secreted from the blood, O2 is absorbed into the blood. Where does external respiration occur? Between the alveoli and the pulmonary capillaries. Then I will ask you, what is internal respiration? And many students are going to tell me this is when you exchange the blood and the air. No, internal is happening right here between your systemic capillaries and your systemic tissues. Pretty much the tissues, everything except the lungs, your muscles, your bones, your liver, your stomach, everything except the lungs. What is happening there? What is happening to oxygen during internal respiration? So what is, remember, we say it relative to the blood. Oxygen is secreted. It leaves the blood and goes into your tissues. What is happening to CO2? It is absorbed by the blood. It leaves your tissue and enters the blood. These are the gas exchanges that are happening during internal respiration and external respiration, and where they're happening. It is not the same as ventilation. Ventilation is what your upper respiratory tract, your respiratory tract is doing, moving air in and out. The gas exchange is happening between the alveoli and the blood vessel, external respiration. The gas exchange is happening between your systemic capillaries and your systemic tissues, internal respiration. This can get very confusing, but I need you to understand this. It's going to become an important concept in physio. When I ask you, what are the two phases of ventilation? What are they? Inspiration, expiration. Let that be the last warning. If you write inhale, exhale, I will not be awarding you any points. Which is breathing in? Inspiration. Between the alveoli and the pulmonary capillaries, which gas is secreted by the blood? CO2 is secreted. That means CO2 is leaving the blood. Over here, what is being secreted? O2 leaves the blood and goes into the tissues. That is the main difference between internal and external respiration. Your upper respiratory helps condition the air. We talked about it helps add the right amount of water vapor. Before I move on, why does air need to have water? Why does there need to be water vapor in air? What needs to be dissolved? Okay, that's an important concept. The gases need to be dissolved in air. What is the gases being dissolved? Sorry, water. What does the gases being dissolved in water have to do with breathing? No water, no diffusion. No water in your lungs. Nice knowing you. That's actually the biggest reason that people perish from fires. The smoke removes the water in someone's lung. They will suffocate, very likely, before they succumb to more worse fate. Why does the temperature need to be adjusted? Why do you want your what's your body temperature? That is a terrible answer. This is a science class. Why does your body want the air to be at 37 degrees Celsius? Diffusion at the same air temperature and your body temperature is going to be fastest. If one of the temperatures is off, it's going to slow down the diffusion rate. If your air is too warm, it'll slow it down the diffusion rate. If the air that you breathe in is too cold, it'll slow down the diffusion rate. So when I say it conditions air, this is what it's doing. And it also removes, it caps, it traps any debris that goes in there. Dust, pet dander, smoke. You ever been out during when there's a fire? You're gonna have some nasty snot coming out of you. It's trapping it all so you can get rid of it. Most of this starts at the nasal cavity. You should be breathing through your nose. Again, the entrance is the nostril to move the air into the nasal cavity. Guess what? You breathe through your mouth breather. What happens when you breathe through your mouth? You lose water. That's why you looks like puff of smoke when it's cold. You lose a lot of water. Body temperature isn't regulated right. And you skip the filter stage. So you're going to get more bad things going into your lungs if you're a mouth breather. But it is a pathway for air. So when you listen to fitness coaches and you need to breathe out of your mouth, what do they say? Breathe in through your nose, breathe out through your mouth. Breathing in through your nose allows the water to be helped conserve it. You do lose it when you breathe out, but the big thing is you still do the body temperature conditioning and the filtration when you breathe in. When you breathe out, it doesn't matter. You lose it to the environment, but it's not going into your lungs. That's one of its major goals, starting at the nasal cavity. The pharynx. There are 3 regions to the pharynx. They're shown here in 3 different colors. This is the pharynx. And I would like you to know the 3, what they do. The one in red, number 1. This is behind, what is this space, number 1 called? That is your nasopharynx. The nasopharynx is designed to move air and air only. You will have people, you will have patients. Trust me, you will have patients who move solids through this. It's a bad thing. You're going to have patients who are going to be coked out. Just you wait. This is designed to move air only. That's why it absorbs drugs rapidly through the nose. The area in blue, number 2, it's behind, what is that cavity called? Oral cavity. So the pharynx, number 2, no thank you. Go away. Number 2 is called your oral, for oral pharynx. This is designed, yes, it'll move air, you breathe in, but it is more designed to handle drink, food, and air. It'll accept them all. Our last one, number 3. This one has 2 names. I don't care which you use. This is behind the larynx, so it is sometimes called the I spelled it wrong already. Brain fart. Laryngopharynx, because it's behind the larynx. Or it's the lowest one, so you can also call it the hypopharynx. Either one. Not only does this move air, food, and water, but it separates. It separates the air from food and drink. That's where the separation occurs. Food and drink go down the esophagus. Air moves into the larynx. You do not want air going into your larynx. That's when you're going to choke. These are the 3 regions of the pharynx. This is how I can ask it. Air that enters the mouth is going to go into which cavity? The oral cavity. Which pharynx does it go into? The oral pharynx. How are you going to answer this question? Where does external respiration take place? Between which structure? Alveoli and which one? Alveoli. Oh my goodness. And pulmonary capillaries. We're not there yet. We're only at the pharynx. Air, once it enters the laryngopharynx or hypopharynx, it will enter the pharynx and then eventually make its way down into the trachea. This is a mid-sagittal cut of the pharynx. The pharynx has a very large flap. This is the epiglottis. It's an L. The epiglottis is the flap that will close this area so food and water do not go down into your trachea. The larynx. does not block the pharynx. Everything that's food or water will stay in the pharynx and make its way down the esophagus. Only the air will enter the larynx. And the reason I erased that is because I forgot. You have two folds, the top one and the bottom one. The one in red are your true vocal cords. They are inferior. Those are the ones you're going to use to vibrate and make sounds. The one up top is not your true, it is your false vocal cords. Those help support those folds below it. So this one is for structure and support. The one below it is the ones you use to vibrate air, to make sound. Both of them, that region makes the glottis. Your voice area where you produce sound is the glottis, hence the name of this one. Above the glottis, epiglottis. Your voice box, your larynx is protected. You don't see it well here, but I'm going to kind of draw it like this. Is protected by the thyroid cartilage. The thyroid cartilage is made of hyaline cartilage, so it's stiff and remains open. These ones below, you're going to see there's one ring, two rings. They actually form rings. They're only half rings right there because they're cut. These are your tracheal. So that's already at the trachea, your tracheal rings. So right there is the border between the lower respiratory tract and the upper respiratory tract. And the tracheal rings are also made of hyaline cartilage so that they remain open. You do not want your windpipe to collapse. You want it to remain open, stiff. So that's why they're made of hyaline cartilage. Once the air makes it to the lower respiratory tract, it's going to enter the trachea. So the trachea is the first part of the lower respiratory tract. And then it splits to become the first set of bronchi or bronchi. The first set are your primary, screw up that word, bronchi, bronchi. Then it splits to become the next group. This one actually goes down to here. Secondary bronchi. Bronchi. It again to become this last group. There's more as they keep splitting. Tertiary. One of the things about them is you're going to see have, I'm just put something else. They are surrounded by hyaline cartilage so that they remain open. Where the cartilage becomes less and less, that's when it starts to become the ends of these branches, which is called the bronchioles. We're making our way to the alveoli. The act of breathing, ventilation. And by the way, this is breathing at rest. Breathing that you would be normally doing when you sleep, when you're not really doing much, not when you're on a treadmill. That's forced breathing. Totally different thing. Similar concept, but different thing. What do we call breathing in? Inspiration. That means air's going in, the diaphragm contracts. When the diaphragm contracts, it pulls the diaphragm down. The diaphragm is pulled down, you expand your lungs. You expand your chest just with that muscle moving down. So what happens is you increase your lung volume. And there's a fun physics phenomenon. Volume increases. Okay. I didn't see who it was, so that's not helping your grade. Okay, that's inspiration. What do we call breathing out? Expiration is weird, especially at rest. Look at what's happening to that figure. What muscle is contracting? No muscles contract for quiet expiration. The diaphragm relaxes and the diaphragm recoils, returns to its original shape. Your ribs recoil to return to their original shape. And when they turn to the original shape, guess what happens to your lung volume? your lung volume decreases, and that increases the pressure inside of your lungs. It moves from areas of high pressure out. No muscles required for quiet breathing during expiration. When you're on a treadmill, you're going to use a whole bunch of muscles. You can literally see your lungs, totally different group of muscles involved there. But this is at rest. Look at the diaphragm. Pay attention to that. Which one's showing inspiration, A or B? A. How do we know A is showing that? Because the diaphragm is moving down. That means the diaphragm is contracting. When the diaphragm contracts, you inspire. When the diaphragm relaxes, you expire. Pay attention to the diaphragm. That's going to be your giveaway. I will include arrows to demonstrate which direction it's going in, but you have to know if it's relaxing or contracting. What was this branch called? And then primary bronchi. The next one, secondary bronchi. This one, tertiary bronchi. And then all of these little bits that branch off of them, that's where the bronchioles are starting. Okay. So the air has to move through those to get to the bronchioles. There are only two bronchioles that I want you to remember. Shoot, and I forgot I included this question. So let's get back to that. Let's stop here to answer. So here it is. Look at how crazy it gets. All right. Let's do this again. The trachea, primary bronchi, secondary bronchi, tertiary bronchi. Now we are here and our bronchioles. Okay. The bronchiole is shown here, and it's surrounded by smooth muscle. Okay. These are the smooth muscle that are going to contract when you don't need to bring in so much air. Why do you want to contract it? To conserve water. Unfortunately, when those muscles overreact, that's what gives someone asthma, wheezing, are those smooth muscles. They contract the airways and they cause problems. But that's how you can differentiate bronchioles. They have a lot of smooth muscle around them, not a lot of hyaline cartilage around them. So that's our first bronchiole. This one right here, before it branches off, it's almost ending. This is our terminal bronchiole. So air is going to go either in or out of this one, the terminal bronchiole. Then the next one where it branches, oh, that's a bad color. Let's use this one. Where it branches, here's the two branches. Each one of those is a respiratory bronchiole. because that is going to lead it into the alveoli. So the respiratory bronchiole is going to move the air into this space. And each one of these sacs, that's probably not showing up well, each one of these open sacs is an alveolus for singular, alveoli for plural. So that's how the air makes it all the way down to the alveoli. Okay. What is this capillary bed, this capillary network? What is that? What are you going to call that? You should know what that one's called by now. Pulmonary what? Excellent. So that blood right there, what are you going to call that one? The pulmonary what? No. Why is it a vein? Because it's returning oxygen-rich blood to the heart. That's what's happening here. So technically, this one is the pulmonary artery. So the blood's going to return to the heart via the pulmonary vein, returning the oxygen-rich blood. Because all the gas exchange is going to occur between the walls of the alveoli. The walls of the alveoli are going to be made of simple squamous epithelial tissue. Why simple squamous? It's thin. It allows for diffusion. Come on. It's these purple cells. These are one thin, simple squamous epithelial cell. So that is the alveolus. You have two types of cells here, and I need you to know what both types do. At the alveoli, you have type 1. This one is a true squamous, a really flat cell. This one is to allow diffusion between the air and the blood. Then you have this other one. You have type 2. These are type 2 alveolar cells. It is this yellow one. These are different. These ones create and release something called a surfactant. These are important fluids. They're going to fill up this space. And what they do is they don't allow the alveoli to completely close. What happens if your alveoli completely close? They're not going to open back up again. So those release a fluid to prevent them from closing and collapsing. It interacts with water. It just keeps the alveoli, which are tiny, it keeps them open. So type 2, keep your alveoli open. Type 1 allows for diffusion to occur between the air and the blood. Okay. I'm sorry? Correct. So it can be collapsed, and that's rough. Right here. That's what's being shown in this slide. This is the interaction between the pulmonary capillary and the alveoli. This is one cell of the capillary. It is made of simple squamous. This is one cell of the alveoli. It is made of simple squamous. So the air comes on this side because this is where the air is. It is inside of the alveoli. This may not look like this, but this is a red blood cell. That's an erythrocyte. It is very important that you understand that each of these is made of simple squamous epithelial tissue. Why? Because those cells are thin enough to allow oxygen in the air to diffuse through two thin layers to make their way to the red blood cells. The fact that they are thin permits the oxygen to diffuse through the walls of the alveoli, through the walls of the capillary, so the oxygen can get to the red blood cells. Smokers. What do smokers get in their lungs? What is that called? Emphysema. That means this gets thicker. What happens when your walls get thicker? Less diffusion. Scar tissue. It's hard for them to get oxygen into their blood because of scar tissue from all the smoke. Thick walls, less diffusion. So this is right here. This is gas exchange between the alveoli and the pulmonary capillary. What type of respiration is this, folks? What type of respiration is this? External. Why is it external? It's between the air and the blood. I need you to understand what is happening here. The blood comes in from the pulmonary artery. It is oxygen poor. As it moves through the capillary, it moves through really slowly because that's what capillaries do. But look, there's a thin layer of the alveoli and the thin layer of the capillary. That's what's permitting diffusion, folks. And as the air comes in, the air during inspiration is going to keep the oxygen levels high in the alveolus. And it's going to allow oxygen to make their way to the red blood cells. The red blood cells are also going to off gas and secrete carbon dioxide. So as they move through, at the end, when they return to the pulmonary vein, they are oxygen rich. They don't have any more or very little CO2, and they're jam-packed full of oxygen. Hopefully some of you guys saw this and got your minds thinking. Come on, tablet. What does it say that little blue line is? It's surfactant and what else? Water. Surfactant's going to help keep the alveolus what? It's going to help keep it open. Exactly. Surfactant keeps the alveolus open. What does the water do? Allows for O2 and CO2 diffusion. Once more, When people encounter and go into a burning building, the smoke is going to remove all that water. And that's the biggest concern when you have smoke inhalation. How much of your alveoli are no longer working? Because it takes a while for them to recover.